So good morning everyone. This week we have had quite a lot of presentation and also poster making reference to Genesis. So what I hope today is to tell you everything you always wanted to know about Genesis, but were afraid to ask. I'm just making this presentation on behalf of the ESA team involved in the Genesis project. So the core team is located in the European Space Research and Technology Center in ESTEC in the Netherlands. And we have strong support from our colleagues at ESOC, Werner and Eric, I'm sure you all know them, as well as Vicente from our operational science site in Madrid. So I will just remind you quickly the highest objective of the mission. A few words about science, but I know all of you have most probably much better understanding and knowledge of the science we're going to do. And then I will really focus on what is the status of the mission and the system and the payload, and how we intend to collaborate and use and share information with the scientific community. Okay, so the primary objectives of Genesis are to support the geodetic community in an effort to improve the stability and accuracy of the ITRF in line with the goals that were set in this UN resolution. And in addition, is also to have a contribution in the ITRF and the coupling between the two. These are the very high-level scientific objectives. On the other hand, we also believe that Genesis will enable new application both in the navigation domain. So if we have better reference frame, we can have better navigation. And by extending the processes and techniques we do on the Earth, we could also potentially extend it to beyond the Earth. And then there is a wealth of other scientific potential benefits and applications in Earth science, either in the surface of the Earth or in the interior of the Earth. And again, I'm sure there are already plenty of ideas of what can be done, and probably there are also some new things that we are thinking today that will be available via Genesis. So just a few programmatics first. So as my profile code is presented on Monday, the Genesis mission within ESA is managed by the Navigation Directorate under the so-called Future Nav program, which is a new program that is dealing with preparing for the future of navigation beyond the existing programs that are EGNOS and Galileo. It is an optional program in the ESA framework, meaning that each country is free to contribute based on their willingness to contribute, and these are the current participating states with a strong involvement of Italy and Belgium. And should you sit in a ESA member stand and don't see your flag here, I recommend you to approach your delegate and support further the mission. In terms of scope, so this is one of the first time in ESA that we are implementing a full project starting from, so it means we are placing a contract with industry for full phase ABCDE. So it means preliminary definition up to launch and operation. So it includes the development of a single satellite together with the ground segment, the launch, as I said, and an early operation of 2 years. And we are now discussing the possibility to extend that. Of course, we will also rely on a strong ground segment, and in particular data acquisition, processing, and distribution. And for that, we will make reuse of our ESA facilities. And finally, so in essence, I think as you all know, it will be the first co-location of the 4 geodetic techniques. So we will have on board a GNSS receiver, a VLBI transmitter, which is today the new thing of Genesis as compared to previous missions, ESA reflector and DORIS receiver. And of course, so these are for the industrial activities, but again, we rely strongly also on the scientific community, so a lot of people within this room. So this is just to show you a bit how we organize the structure of the mission. So ESA is managing the whole mission. We have an industrial part, and I will come back to that. So we have the industry is building the satellites as well as the ground segments, and we will be operating the satellite. And we have the scientific community of equal importance for the mission. So just in terms of planning, so we kicked off the industrial activities in April, and now we are working very hard to the system requirements review, where we will freeze all the specification. Then we start the preliminary design of the satellite and of the whole system, in fact, critical design, and we plan for launch dates in 2028. Just the system overview, so as I said, I think I will skip that one, but basically the system includes the satellites, then we have the 4 instruments, and the mission phases, the traditional one. So maybe satellite and payload, so we have quite a lot of technical drivers for the establishment of this mission. So in particular, we know that this 6,000 kilometer mission altitude is very harsh in terms of radiation environments, and this is really something we have to look carefully. We need to make sure that we have also proper, that the onboard electromagnetic compatibility is safe, so that the instruments are not perturbed like that. We have to make sure that the satellite design is also, that we have all information so that all gravitational forces can be properly estimated, or yes. We have also specified very stringent requirements for the knowledge of the center of mass, the knowledge of the phase centers, etc. Okay, then on the payload themselves, so we will have a multi-channel GNSS receiver. We will have 2 antennas, nadir and the zenith pointing, and the receiver will be externally synchronized to the onboard oscillator. VLBI transmitters, so this is one of the first. So we have now selected 4 frequency bands within this very wide band that will be in fact fully compatible with the Vigos ground stations. We are still defining what will be the power level at the receiver side, at the antenna side, and this instrument also will be externally synchronized with the onboard oscillator. So the laser retro reflector, this is a passive, the passive instrument. So it will be done based on an array of corner cube reflectors. The design is not yet frozen, it's still under design. But here again, we will have very stringent requirements on the field of view, the cross-section, thermoelastic effects, accommodation, and PCO calibration, as for the other instruments. And we'll also have a DORIS receiver. Here the main challenge is how this instrument behaves. We will have the same performance at 6,000 kilometers than in LEO. Also, the radiation environment will have to be properly addressed. As you know, we see already on the existing DORIS in LEO the impact of radiation on the self-Atlantic anomaly. So probably we'll have to shield some specific parts, or maybe the whole instrument. This is still to be done. Now, so this is for the instruments. Now, regarding the data, so the data will be directly accessed from the satellite to the ground center, and then will be stored and processed at the PROAD, which is the center which will be responsible for the processing and archiving and distribution of the data. This will be located at ESOC. And we will receive the data from the external services, SLR, VLBI, GNSS and DORIS. So now the interface with the scientific community, as you say, it's mostly a mission for the scientists. So for us it's very important we keep a very good and very strong relationship with the scientists. So we have established this structure now, which we have a high-level, what we say, GNSS Science Management Board, which is composed of ESA representatives together with the so-called lead scientific coordinator and co-coordinator, as well as the chairs of 5 working groups that are described below, and I think a lot of you are involved in those working groups. Just to mention that the strong relationship between scientific community and the GNSS team will be really extremely important for the success of the mission. And I think also a lot of you have attended this workshop in ESOC back in February. At that time, the industrial contract for the mission was not yet in place. So as I think we could not officially start the activity, but now the activity has started, and as I said, the next milestone with industry will be end of September with the system requirement review. So in the meantime, what we have done is that we have nominated the science exploitation team, so the coordinator, I think probably you know all of those people, but the scientific coordinator is Osgo from the Royal Observatory of Belgium, and the co-coordinator Francesco Vespe from the Italian Space Agency. And you have the chairs of the working groups that have also been nominated, and how the working groups are being established. So, just to conclude, I think maybe I forgot to say, but for ESA it's a very, very challenging mission because it's in one go phase A, B, C, D, E, with a very tight schedule. So it's a lot of pressure that we have on our side, and we also know that there is a very high expectation from the scientific community. But this is why we believe it is really essential that we keep a good cooperation and a good exchange of information between the ESA team, the industrial team, and the scientific community. This is the end of my talk. Thank you.